Forest River just recalled their Riverstone fifth wheels, 2018 through 2026 models. 8 years of production, thousands of units. The issue? Brake line failures. Picture this, your family descending a mountain pass at 60 miles per hour. You press the brake pedal and nothing happens the way it should. Here's the thing, after 2015, Thor Industries and Forest River made a decision. Chinese brake components, $40 instead of $120 OEM. The accountants ran the numbers. The engineers never got a vote. Your safety became a line item. I'm going to show you which components are failing, why they're failing, and how to know if your RV is rolling on borrowed time. The upgrade that could save your life on a 6% grade is coming at the end. When you buy a $40 Chinese caliper instead of a $120 OEM equivalent, you get undersized pistons, 30 millimeters instead of 34 millimeters. That's reduced clamping force when you need maximum stopping power. Forest River and Coachman learned this the hard way. 2020 recalls for loose caliper bolts. 2022 recalls for backward installed axles. But here's what the recall notices don't tell you. Mechanics are filing down Chinese calipers before they'll even fit. The mill quality is mediocre. The torque specs are wrong. No Loctite on critical fasteners. One mechanic said he was stymied by a flood of cheap parts requiring modification just to install. So what does this mean for you? You're grabbing the brake pedal coming down a grade with your 35,000 pound fifth wheel. The caliper piston seizes from substandard machining. Or worse, the caliper body fractures under pressure because the material specs weren't right. You're doing 60 miles per hour on a mountain descent with your family on board and suddenly you have no stopping power. That's the $40 gamble from Shenzhen. RV manufacturers spec brake rotors for cost, not capacity. They're using cast iron rotors, lighter and less dense than comparable vehicles. Mechanics report these rotors stay stupid hot even an hour after driving. You spray water on them and it instantly vaporizes. That's not normal heat dissipation, that's a thermal management failure. Look at Subaru Ascent. They built a 3-row SUV with rotors undersized for the vehicle mass. Original design, 41 cooling fins. After widespread warping, they redesigned with 47 fins, 15% improvement. If Subaru got it wrong, what happens with RV manufacturers chasing quarterly earnings? Most Chinese rotors last 2 years maximum. Quality OEM rotors go 5 to 7 years. The material quality control isn't there. One company admitted they had to replace all the forms in their outsourced dies because the material specs weren't right. Picture your fifth wheel descending a 6% grade for 3 miles. You're riding the brakes continuously. The rotors start glowing blue from the heat. That slippery coating forms on the surface. That's the molecular structure of the metal changing under heat stress. The brake pedal goes soft, then to the floor. Complete thermal failure. They save $12 per wheel. You lost your stopping distance when you needed it most. Here's the thing about brake pads and heat. Above critical temperature, pads start to gas out. They form an air cushion between pad and rotor. The pedal stays stiff. You have full pedal pressure, but you have zero braking power because there's literally a layer of gas between the friction surfaces. Original equipment pads deteriorate from extended sitting, typical RV use. One service center documented this. The pads manufacturers install are good quality, but not the best. They deteriorate when the RV sits for months between trips. Industry data shows 16 to 17 million new cars get quality pads, but 100 million brake jobs happen yearly, and most use cheap pads. Why? The aftermarket parts industry is worth $273.4 billion. Insurance companies push for cheapest fixes. When pads cost $8 instead of $35, someone's profit margin became your safety margin. You're descending a long grade. The pads heat past their threshold. They gas out. You have full pedal pressure but an air cushion between pad and rotor. It feels fine until it doesn't work. By the time you realize what's happening, you're in a runaway situation. If you're realizing your RV might be rolling on these components, hit subscribe. You deserve to know what you're actually buying. Most electrical malfunctions come from poor connections, broken wires, or insufficient wire gauge. 18 gauge wire versus 10 gauge, minimal cost difference. Catastrophic performance difference. 18 gauge can provide 16 amps to the system, 4 amps to each electromagnet on a 4-brake system. Sounds adequate, but when that ground wire is 50% broken from repeated flexing, amperage drops. Since brakes are a significant electrical load, a faulty ground limits the amperage delivered. One owner traced weak brakes to a ground wire that looked fine but was 50% broken internally. Multiple RV recalls for incorrectly wired 7-way harnesses. The trailer brakes don't receive proper voltage, so you hit the brake pedal hard in an emergency. The controller sends a signal, but because someone used 18 gauge instead of 10 gauge, or because a ground connection is corroded, inadequate voltage reaches the magnets. Your truck stops, your trailer doesn't. 15,000 pounds pushes you through the intersection. The difference between a $40 controller and a $200 Tucson Direct Link is the difference between hoping and knowing. One connects to your vehicle's computer network and monitors multiple parameters. The other is a timer and voltage regulator. When controlling 15,000 pounds, hope is not a strategy. American RV motorhomes use phenolic pistons instead of steel, presumably for heat transfer reasons to prevent brake fluid from boiling. But phenolic has a critical flaw. It absorbs moisture. Over time, these pistons absorb moisture like a sponge and become oval. When you need them round, they're oval. One service center documented this extensively. The twin piston calipers are particularly affected, and steel replacement pistons are unavailable. The manufacturers never produce them. Your hydraulic system depends on precise tolerances measured in thousandths of an inch. Your piston is no longer cylindrical. It's absorbing moisture and changing shape. Pressure leaks past seals. You get soft pedal, long travel, reduced stopping power. They chose a material that absorbs the one thing it should never touch, water. One of you commented, "My pedal goes soft after sitting for a month." Now you know why. Moisture. In your phenolic pistons, it's not you, it's them. Flexible brake hoses deteriorate internally and externally. Externally, rubber shows cracking. Metal clamps corrode away. But internal deterioration is worse. The brake fluid breaks down rubber internally, restricting fluid return to the master cylinder. Here's a design mismatch. Ford and Workhorse chassis are built for delivery trucks doing 200,000 miles of constant use, not RVs doing 5,000 miles and sitting 11 months. Your RV spends most of its life stationary, and sitting is the main cause of brake problems. You release the pedal after a stop, but fluid can't return because the hose diameter restricted. Brakes stay partially engaged, dragging, overheating, or the line ruptures during hard braking, total hydraulic failure. The chassis was built for constant commercial use, not RV use patterns. Wrong application, wrong assumptions. Cast iron rotors corrode when left on damp ground. If left long enough, this affects the rotor surface. But it gets worse when rotors overheat. When a rotor gets too hot, the color changes. It becomes blue and shiny with a slippery coating. That's not cosmetic, that's the molecular structure changing under heat stress. Chinese rotors have inconsistent material quality. After a year, owners report Chinese rotors shuddered badly enough they reinstalled originals. One mechanic switched suppliers after bad experiences. He didn't want unhappy customers and didn't want to do brake jobs twice. The mass of the rotor matters. Check the weight. Heavier is better. Lighter rotors have less thermal mass. They can't absorb as much heat before failing. Your rotor surface is compromised from corrosion before you leave storage, or it overheats on the first mountain descent because thermal mass isn't adequate. That blue color, metallurgical failure. The slippery feel, your safety margin evaporating. Brake fluid is hygroscopic. It absorbs moisture from air. Over time, moisture gets into your brake fluid through microscopic pores and hoses, through the reservoir cap, through every entry point. This moisture lowers the boiling point. Fresh .3 boils at 401 degrees. With 3.7% water, that drops to 320 degrees. RV maintenance intervals ignore fluid replacement. The schedule says check fluid level. It should say replace fluid, test for moisture, and pray you catch it in time. Those phenolic pistons, they're contributing additional moisture to your system. When brake fluid heats to boiling point, viscosity decreases and alters hydraulic function. This is brake fade. It renders the system null and void. You're descending a 6% grade for 3 miles. Brakes heating up, heating up, heating up. The contaminated fluid hits its reduced boiling point. Vapor lock occurs. Pedal to the floor. Nothing. No brakes. The schedule says check level. It should say replace annually because moisture. Contamination is inevitable. That's the difference between maintenance and prevention. Here's the thing about RV brakes. The era of over-engineering for safety is over. After 2015, accountants made the call. $40 instead of $120. Shenzhen instead of quality OEM. Your safety became a line item in a spreadsheet, but you don't have to accept their choice. Dexter axle systems with proper weight ratings. Tucson Direct Link or Teekenshay Prodigy P3 controllers. Proportional, not time delay. Quality rotors. Textar from Germany, EBC from UK and US, Akebono from US, Japan and France. Annual brake fluid moisture testing and replacement. Severe duty brake pads, not original grade. Check country of origin stamps on calipers and rotors. Verify wire gauge on brake controller circuits. 10 gauge minimum. Test controller voltage at magnets. 12 volts under load. Look for blue discoloration on rotors. Check brake lines for cracking. Stop shopping like a victim and start thinking like an auditor. Your RV manufacturer chose profit margins over stopping distance. You can inspect what they installed. You can upgrade what's failing. You can verify that components between you and a runaway situation are capable of doing their job. Subscribe, because knowing what's under your RV might just save your life. Don't let them take your retirement savings, and don't let them take your safety.